Before the car can start to move down the road, it has to take some time to prepare before beginning. As we can see, we have a car with bumper stickers and a license plate. Our setup consists of a road and a main street. Biologically speaking, our car represents RNA polymerase, and the bumper stickers attached to our car represent various proteins, which are collectively known as transcription factors. Transcription factors help bind the RNA polymerase to the promoter, which is represented by the first road that the car is going to connect to.
The promoter is simply DNA sequence that starts transcription. You may notice that our license plate reads TATA, which is meant to depict the TATA box. However, it is important to note that in actuality, the TATA box is simply a sequence on the promoter which allows for RNA polymerase to bind to the promoter. This whole process is collectively referred to as initiation. Our car connected to the starting road with all its different items intact represents what is called a transcription initiation complex.
The portion of DNA that is being transcribed is known as a transcription unit, which in our case is our main street. Beginning at the start point, our car will move down onto the road. Let's pretend that this was a magical car, and as it moved along the street, the road slowly separated and then connected back together after the car moved past that point. In actuality, as RNA polymerase is moving about the DNA strand, it unwinds it as it moves along and elongates the RNA transcript simultaneously. The DNA strands assume their original helix shape after the RNA strand has passed through that point. Notice that along the way, we have speed limit signs 5 and 3. Keep in mind that when elongation occurs, it does so by transcribing in the 5' to 3' direction.
The last step involving termination. In our case, the car will disconnect from the transcription unit. What this means is that the polymerase will detach from the DNA. After this occurs, the process is complete.